Okay, so here's a packet I made for extra practice on this topic. I've linked it in the comments. You can either print it off and do it ahead of time and use this video to check your work, or you can work along with me. So our first thing is going to be to do f plus g of x, which is just f of x plus g of x. So we write in f of x plus g of x. Since we don't have any distribution of a negative, we can just drop the parentheses and combine like terms. So 3x squared plus x, negative 4 plus 2 minus 2. Okay, now for f minus g, which again is just f of x minus g of x. Okay, so this is where it'll be a little different. We have to distribute that negative through. So we get 3x squared minus 4 minus x minus 2. So that result is minus x minus 6. Okay, now for f times g. Okay, so this is f of x times g of x. Okay, for that, 3x squared minus 4 times x plus 2. And now we FOIL. So the first terms, 3x cubed. The outer terms, that'll be 6x squared. Inner terms and outer terms. Check to see if you can combine any like terms. We can't, so we're done. Okay, the last one is going to be f of x divided by g of x. So we have 3x squared minus 4 over x minus 2. Now, at this point is very important to check if you can factor out this numerator or the denominator and see if anything will cancel. But here, that's in its lowest form, and so is that. So we can't factor or reduce. But the thing we do have to be wary about is the restriction. So for the restriction, you set the denominator equal to 0, solve for x. So here, x cannot equal 2. Right? Okay, so now for f of g of x using points. So for f of g of x, okay, we're going to start with putting the x values of the g function. So f of g of negative 11, f of g of negative 2, f of g of 3. Now we evaluate the g function here. So we get f of what is the y value that coordinates with the x value of negative 11, 2. Okay, same thing here. What is g of negative 2? Negative 1. And what's g of 3? Negative 3. Okay, now we go to the f function and see if we have a corresponding y value for these x values. So do we have a f of 2? Nope. Do we have a f of negative 1? Nope. Do we have a f of negative 3? Yes. So negative 2. So our only point in f of g of x is our input was 3, our output negative 2. Okay, now we do the same thing for the g of f of x. So g of f of 5. g of f of -3 and g of f of -8. Okay, so f of 5, that's 13. F of -3, -2. F of -8, -11. All right, so let's see if we have a g of 13. Nope. Do we have a g of -2? Yes, -1. Do we have a g of -11? Yes, 2. So our points that go in, that have come out of g of f of x is -3, -1, and -8, 2. Okay, now we're looking at f of g of x, but using equations this time. So for f of g of x, remember we're actually putting in this equation into every x of f. So if it helps you, you can write the g function in here. Okay, now we go to the f function, we start writing the f, and whenever we get to an x, we put parentheses and input the entire equation. And then finish off the f function. Okay, now you simplify, so we'll have to distribute first. And then finish off. And now combine like terms if possible. Okay, so that is our f of g of x function. All right, now let's do g of f of x. Again, if this step helps you, go ahead and write it. Okay, so we start writing the g function. When we get to an x, input it in, squared minus 4x plus 3 plus 1. Okay, so first we'll have to distribute this, or FOIL that. So off to the side, let's do that. So we have 4x plus 3. Okay, so we get 16x squared plus 12x plus 12x plus 9. So we get 16x squared plus 24x plus 9. Okay, so we go back in here. 2 times that whole thing. Okay, and don't forget we have to distribute that negative. And then finish off the equation. Okay, now we get to distribute the 2. So we get 32x squared plus 48x plus 18. Oh, and let's go ahead and combine those. One last step. So -3 plus 1, -2. Okay, combine like terms. No more squares. So plus 44x. And then 18 minus 2 plus 16. And that is it for g of f of x. Okay, now we'll do f of g of x, but we're actually inputting a value for the x instead of finding an equation. So our first one we'll do f of g of -2, but we start off with this, so we do -2 squared plus 3, -2 plus 1. So -2 squared 4. 3 times -2, -6 plus 1. 4 minus 6, -2, -2 plus 1, -1. And then we just plug that into our f function. that equals -3. So the point is our input, -2, our output, -3. So our x and our final y. Okay, same thing for g of f of 3. So g of f function, and then the x value. So that gives us g of 9. And we just do the g function. So 9 squared plus 3 times 9 plus 1. That gives us 81 plus 27 plus 1. We get 109. So we get 109. So our actual point is 3, 109. Okay, so finding the inverse. Remember, when you're dealing with points, you just switch the x and y. Because remember, inverse is just the reflection across the x equals y line. So f inverse of x is 3, 4, 10, -2, and -7, 6. Okay, now for the inverse of an actual equation, remember your first step is to change the f of x to y, switch the x and y, solve for y, and then switch, or I shouldn't say switch, but change the y to f inverse of x, because now you found the inverse. Okay, so first step, y equals x plus 1 squared plus 3. Switch the x and y, so x equals y plus 1 squared plus 3. Now solve for y. So we're going to subtract that 3 over. Okay, to get rid of a power of 2, we're going to square root both sides. And now move that 1 over. Okay, last step, change the y to f inverse. So f -1, or f inverse, equals square root x minus 3 minus 1. And make sure that minus 1 is outside that square root sign. Okay, now how to tell if these equations are inverses of each other. So you can do this one of two ways. You can either find f inverse or g inverse and compare. Or you can do f of g of x, which has to equal x, and g of f of x has to equal x. Either way is correct. So for this one, I'm going to find f inverse and compare it to the g of x. Okay, so first thing, y equals -1/3 x plus 3. Switch the x and y. Now solve for y. Okay, divide by a fraction, multiply by the reciprocal. Okay, so we get -3x plus 9 equals y. Okay, Now, is that exactly what we have here? Yes. So yes, they are inverses. All right, so for the next one, I'm actually going to do the f of g of x. Okay, so the 6 is over 1, so those cancel. So negative times that gives you a negative x. So no, these are not inverses because you need to come out with a positive x. Okay, reducing the radical. So the first thing you want to do is reduce the coefficient here. So what perfect square, since we're dealing with the understood 2, what perfect square goes into 50? So that'll be 25 times 2. Okay, and rewrite your variables. That's supposed to be y to the 7th. I don't know why it came out that way. Anyway, so now we square root the 25, so we get 5 y to the 7th. Okay, now we break down the powers. So we need to break these powers down into multiples of 2, and then what's left over. So what is the closest multiple of 2 to 3 without going over? Okay, that would be 2. So we're going to separate that into x squared times x to the first. And what multiple of 2 is closest to 7 without going over? That would be 6. So y to the 6th and y to the first. So now when we square root this, we get 5. Okay, remember there's understood 2 out here. So 2 divided by 2 gives us x to the first. When we square root the y to the 6th, 6 divided by 2 gives us 3. So y cubed. Finish out with what's left, 2x and y. And that's it. Okay, so for number 11, let's look at our list of perfect cubes. And what perfect cube is 24 divisible by? So that would be 8. Okay, so we're going to separate this into the cube root of -8 times 3. And then finish off with our variables. Okay, cube root the -8, that'll be -2. And what's left? Okay, now deal with the variables. Okay, so now instead of looking at multiples of 2, we're actually looking at multiples of 3. So is 9 divisible by 3? Yes, so we can leave it as a to the 9th. Is 20 divisible by 3? No, but what's the closest multiple of 3 to 20? That would be 18, so b to the 18 and b squared, because 20 minus 18 is 2. Now, is 3 divisible by 3? Yes, so it gets to stay there as well. And now we cube root. Okay, a to the 9th, 9 divided by 3, a3. B to the 18, 18 divided by 3, 6. And 3 divided by 3, 1. Cube root, what's left? We have a 3 and a b squared. Okay, now for division. So when you have this, remember you have to separate it into 2 different square roots. Okay, now we reduce the radicals if we can. So the perfect square that goes into 20 is 4. It's 4 times 5. And is 5 divisible by 2? No. So we're going to separate that into a to the 4th power and a to the 1st. B cubed, 3 is not divisible by 2. So we're going to separate that into b squared and b. Okay, reduce those radicals. We have 2 a squared 5a over b square root b. Now, since we can't have a square root in the denominator, we're going to multiply top and bottom by root b. Okay, outside times outside, 2a squared. Inside times inside, 5ab. Outside times outside, b. Inside times inside, b squared. Okay, so this square is divisible by 2. So our final answer is over, pull that out, it'll be b times b, so b squared. Okay, now for reducing the 4th root with division. So again, separate it. Okay, so since we can't reduce anything right now, except possibly this y, yes, let's do that. Okay, 4 divided by 4, just 1. 4th root, 2x. Okay, so our goal here is to multiply this by something so that this denominator will not have the 4th root in it any longer. So we're going to multiply it by something, top and bottom, exactly the same. But what we want to ultimately get is, okay, so we look at our fourths. We want to get this 16, okay? Because that way, when we take the 4th root of 16, we get 2, okay? So what do we multiply? Oh, and don't forget the x to the 4th. So we go 16 divided by 2, 8. X to the 4th divided by x, x cubed. So let me go over that step again. You want to look at your perfect fourths and see which number 2 can go into, okay? And you want to choose the lowest number because that'll just make your life a little bit easier. So since 2 goes into 16, that's why I chose it. Okay, then you take 16 divided by 2 gives you 8. X to the 4th divided by x gives you x cubed. Now we know what we're going to be multiplying by. Okay, so 4th root, 8x cubed. Okay, so now do outside times outside. Well, that's just 1. And now inside times inside. 3 times 8, 24. X cubed times x cubed, x to the 6th. And then we don't have any y's. Okay, now we reduce the radical. So what perfect fourth is 24 divisible by? Okay, look at our list of fourths. Is 24 divisible by any of these? No. Okay, so that can stay. Is 6 divisible by 4? No. So we have to break it down into y to the 4th. I'm sorry. X to the 4th times x squared. And the y will just have to stay. Okay, now we have y times, okay, 4th root of 16, we already said was 2. fourth root of x to the fourth, just x. Okay, so now we just fourth root the x to the fourth, 24 x squared y all over 2xy. And now this is a really important step. You make sure that anything outside the radical can reduce, which it can. We have an x and we have an x. So now our final answer is the fourth root, 24x squared y all over 2y. Okay, so now multiplying with radicals. So again, outside times outside, 24. Inside times inside, so 5 times 10, 50. Y times y, y squared. Don't have a z, so we just keep the z single. Okay, now reduce. Again, what perfect square goes into 50? That'll be 25 times 2. 2 is already divisible by the 2, so we keep that. And we can't reduce the z. Okay, so square root the 25, we get 24 times 5. Square root the y squared, y. And what's left? The 2 and the z. Okay, then we multiply these out. We get 120y square root 2z. Okay, so adding and subtracting radicals. Very important that you understand you cannot add or subtract unlike radicals. Okay, so if we had radical 2 plus a radical 3, we can't add those together. So first thing we're going to do is reduce these radicals. So what perfect square can go into 28? That'll be 4 times 7. What perfect square can go into 75? 25 times 3. And what perfect square can go into 63? 9 times 7. Okay, reduce the radical. So square root of 4 is 2. 2 times 4 is 8. Square root of 25 is 5. 5 times 8 is 40. And square root of 9 is 3. There's nothing out there to multiply by. Okay, now we see if we can combine any like radicals. We can. We've got a root 7 and a root 7. So we do 8 plus 3, 8, 9, 10, 11. 11 root 7 minus 40 root 3. And that's as far as we can go. Okay, so for imaginary with powers. So remember, our step here is to take the 39 and divide it by 4. Okay, 4 can go into 39 9 times. And whatever our remainder is, that goes there. And now if we have I to the first power, it's just I. I squared is negative 1. I cubed is negative I. And I4 is 1. This is also, if you have a remainder of 0, this is also I to the 0th power. Same thing. So since we have I cubed, it's just negative I. And that's your answer. Okay, so our first step here, we need to isolate the square root first. So what we're going to have to do is add the 4 to both sides. So we get square root 2x plus 5 equals 7. Now to get rid of the square root, we square both sides. 2x plus 5 equals 49. And then we solve as normal. So subtract the 5. 2x equals 44. Divide by 2. X equals 22. Okay, so now we have to check for extraneous solutions. So we plug it back in. Okay, so we get 44 plus 5. So that would be 49. Square root of 49 is 7. Is 7 minus 4 equal 3? Yes. So our answer is 22. All right, so for this one, we do have a square root on both sides. So the square root's already isolated. This one's the more simple one. So this will be the easiest to square. So we're going to square both sides. So we get x plus 7 equals, off to the side, I'm going to do this. First, outer, inner, and last. Combine like terms. Okay, go back over here. 9 minus 6 root x plus x. Okay, so we're going to subtract the x over. Well, that cancels. And we're going to subtract the 9 over. So we get negative 2 equals negative 6 root x. Divide both sides by the negative 6. And now square both sides. So 1/9 equals x. Okay, so now we check for extraneous solutions. So we're going to do square root of 1 divided by 9 plus 7. Okay, and then 3 minus square root 1 divided by 9. And they match. Okay, so for our last one, again, same thing as above. We're going to square both sides first. X minus 15 equals 3 minus square root x. Oh, we did that above. So that gives us 9 minus 6 square root x plus x. Subtract the x from both sides. We get negative 15 equals 9 minus 6 square root x. Subtract the 9. Negative 24. Negative 6 root. Oh, I don't know why I put a 6 there. There we go. Divide by negative 6. 4 equals root x. And now to get rid of that root, square both sides. So 16 equals x. Okay, again, we're going to check. So we have square root of 16 minus 15. And then 3 minus square root 16. Those do not match. Okay, so no solution.